So Tyler, for those who don't know me, I'm going to give just a brief overview of some kind of architecture level stuff, as well as just a high level idea of what GINAS is. This you've already heard before in various presentations, so say it enough time it becomes true. So we have a short list of collaborators here, and there really are very many more people than this. But we've this effort has been a collaborative effort between so many different agencies and organizations, and we have on our website a large puzzle piece together trying to show all the organizations. Eventually, we just couldn't put this that many more in. So, but this is just a quick thing of some of the high level people who've been involved for quite a long time. I just want to say that this is, of course, identifying substances is really essential in order to be able to go any farther in identifying all sorts of things for regulators. So if sometimes what happens is people will repeat the same substance information over and over again and give it to regulators, and they completely identify that these things are the same, and that to have someone keep on qualifying the same thing over and over again is very we think that we really need to have both regulators and industry understand what substances really are and have some sort of common language to discuss these, because these are different implementations across different areas, and it's not really compatible, and that's sort of some of the reasons why we want to go into these kinds of efforts. So just we discussed these things a little bit before. These are the reasons why we think we need that global standard there, so that we have some sort of common language to describe these things, some set rules to distinguish something is new and when something is different, and when something's a variation on another thing. There's E for ingredient substance database. So as to reiterate, we really think that these things are extremely important in order to qualify anything else. I'm just going to skip over the slide. We've all kind of beaten this horse very dead. So the whole plan of this project of ISO 11238 implementation, that there's something global ID for all classes of drug-related substances, and kind of a side path of that is that there could be a single place for registration and depositing of that information. This is a distinction that Beta was trying to make, of course, between the GIS and then the GINAS system. We've as part of the GINAS effort that there could be a centralized base for all the stuff we've been. That's the second point. But also just that there's some unique way to qualify all this. It can be done by the standard, which GIS, the software does. Or intended. So the plan was to make a freely distributable tool for that. So again, this is the goals were to develop and deploy an information system that can serve as a global repository for definitional, regulatory, and scientific information on substances. That's for both these, both for knowing what something is, how it's used, and where you can find it. We established a consortium of regulators and other international organizations to maintain the government repository. So far, we have an informal group of people, as Larry's mentioned before. This is not as of yet an official organization in any sense. There are plans for this somewhat, and also the goal is to distribute an information system and software to both regulators and companies and other interested parties to facilitate registration into the global repository. So that's the system software, or GIS. The fundamental goal of this whole thing is that we think that if you have a common system and common content, you have a better system and better content. And that's for the most part true. If everyone is working just to make their own little part of the universe better, it's much better that same part of the universe spread out 22. So the general overview, I think you've seen the slide now probably twice today, or some variation of this, of just these things tend to connect to each other. So the plan is that there could be that GINAS centralized system where different interested parties can register and receive information from. Meanwhile, can also be found down here. Used down here, the same implementation of the software behind some firewall, whether it's at the FDA or it's at some drug now to get into the actual what is it kind of thing. The software is a freely distributable system that implement the ISO 11238 standard and provide a global identifier for substances. It's capable now of registering diverse substances and specified substances, including chemicals, proteins, nucleic acids, polymers, and structurally diverse. Features is the other one that's not mentioned here explicitly. A central repository for substances and dimensional identifiers. The software itself can act as a central repository for whoever would like to use it. And this includes it also includes information that's related to substances, not just the definitions, but things like physical properties, which are sometimes considered to be definitional, but often are just interesting points of how valuable is this thing, what's the viscosity, melting point, and so on. Indication of information also shows up in there for most right now just informational about impurities and properties and things like that related to giving drug substance. What it usually has as well is some manufacturing information at the higher group level groups, groups. This is including information about companies and facilities and process. At the moment, this is not included, but there are plans for this to expand into that area. It will also include things about toxicological information and other information that's just useful for metabolic show up there in its relationships, so we can see many of the things that have been found to be metabolized. The software also right now is capable of keeping confidential information, having some flat each piece of information, say what level these things are releasable, what level these, who can see it, when they can see it, and how they can share it. So all this has been discussed before. This group meeting that we that was hosted by P and us in February of 2013, so we're going on about 2 years now. We set this up sort of, I guess, it kind of out of the NBC thing to some extent. The NCATS was trying very hard just to identify all those substances that are inside of drugs that are used that are approved, and answering that question turned out to be very, very tricky. And one of the biggest reasons was that nobody was sure exactly what a drug was or what a substance was or what anything, specifically. So giving it a finite collection turned out to be very hard, and then this sort of, we kind of meandered into this group. So there is developed by us, NCATS. The content is managed by the regulators. Initial deployment is hosted at Health Canada, so we have a Health Canada deployment of software that you could all use. There are different collaborators, from these all these agencies. And like I said, it contains many of these much information about a lot of different substance classes. In addition to being able to deploy Health Canada and some sort of enterprise level solution, so take the software and run it in-house on your local machine. And that's what the second part of today is really about, helping people install the software where they would want to use it and get familiar with it. So that's one of the goals of this project, was to be able to do that, and we're going to try to demonstrate that. And this is, the software itself is meant to be distributed with a fundamental core set of data. So it's not just an empty database, but it actually has the application along with some sort of guideline how it is that you're going to go forward. So you have some reference to say, oh, this is how this stuff is done, and so on. So just kind of some background about who we are. For those of you who were earlier, GINAS, I went over this a little bit, but the National Center for Advancing Translational Sciences, NCATS, the newest of the institutes at NIH. It's interesting, actually, we're apparently the only institute in NIH that has a verb in our title. So I use the word interesting, kind of, maybe that's not quite right, but so most of the other ones are dealing with very specific things. Our purpose of this is to always be help, not even to do translational sciences, but advancing translational sciences. Where there's some place that there's a clog in the machine, we're trying to help people figure out how to unclog. So we're highly collaborative across NIH and other governmental agencies, and the main things we were told to sort of focus on are the 3 Ds of developing, demonstrating, and beyond software as well for generating and managing and mining data. We've developed systems in collaboration with domain experts, headed by contract is usually the way to go. So we just identify a need and then talk with the experts on how to go with that. But in this way, we can kind of set up some of the difficult issues and really, some of the tricks. So what we use a lot around here is that we try to analyze things. We're analyze the generation of innovative methods and technologies that will enhance the development, testing, and implementation of diagnostics and therapeutics across a wide range of diseases. This statement is fairly, specific to therapeutics, but really the fundamental. In order to go forward, we have to be able to make sure we're talking the same language, and we think fundamentally having definitions for substances and information are prerequisites to doing things well. So, as I said before, we try to address some of the bottlenecks in the process of translation. This slide that the FDA provided to us, just trying to say why is that FDA has decided to work with us. And, as I mentioned previously, one of the reasons that is that the standard is fairly complex, and right now there's no commercial off-the-shelf software that does these things that we're trying to do. And this is sort of a research effort that we have to go forward to make sure that this is doable, and then we have to actually do it. Likely that any vendor would be able to develop this software without a great deal of continuous input. And so, we're kind of uniquely positioned to be able to do that flexibly. Also, just have in-house expertise both in the and development field as well with the free biotechnology and so on. Just kind of finish up this slide. So the development strategy that we have was the courseware developers have intimate domain knowledge and experience with the regulatory process. So Self and Trung and Noel and several of our other developer people have been dealt with both defining substances for quite some time, and worked with Larry and Frank and many of the other experts in really understanding how this process works and what it means for this regulatory. Our development cycle has been very iterative. So what we did is we put together functional requirements through an in-depth case studies, in-depth case studies with users and experts. You can find those case studies located in this URL. So basically, we've gone through and said, here's some of the most diverse substances we find. In all of substance space, finding the points that are farthest away from each other and making sure we have some way of managing them and walking through what that would look like. For you, those who are interested to look through those initial documents and see how we want the workflow to go. We'll be in those. I think there are a few that are missing on this that we'll have to add in the near future. We've done that. We've had developed discussion and feedback from these studies that drive the design and development. So as these case studies are being done and showing what these things would look like, we're also developing and then giving presentations to our local group.
Are they correlated, or is it
actually it's very high level. So in order to make the conversation accessible to all parties, we are mocking up interface level thing. What would you actually see in a visual web front end in order to go forward? The data model associated with that was not part of these case studies directly, so we can make that the meaning of them as a data model available to you if you like. So as we go forward, we evaluate and implement those features based on those usability studies. And all this information is based on core on the ISO 11238 standard. We went forward by saying, starting from this, looking at what's implementable and also what people would expect to see in a system as they're going forward. And when you merge those three things together, you slowly get towards what we think is very useful and maintainable. Specific goals of the software would be self-contained and modular, so that you could run it entirely on a desktop or across or access it remotely. So we'll get into that a little bit later on today. We can install this locally on your machine, or you can just hook up to one of the servers that we already have running, and then you can use it from those. As digital and predominantly open source, we have well-defined data access application programming interface. We have well-defined APIs for people to use, which really makes it easier for other third-party developers to come in and make some useful tools to use that information. We have fine-grained control of access, so that each piece of information has an access control flag, so you can get out some amount of information, and you can flag certain information to be available to certain groups. So there's an audit trail that's associated with all of the interactions with the database, and configurable business rules, and as we're working to develop these, standardizing, for instance, structures and standardizing other things. All data is referenced. Right now there's very few unique facts that are introduced in the system without having somebody say at least where they got this fact from. So there's a complex or there's a sophisticated level of referencing, not just the PDF, MS spectra, or images to say, well, how it is you, for instance, elucidate the structure and so on. The system is distributed with a large set of public data, as we mentioned earlier, and this will be updated periodically. So here's an overview. The architecture is that we have a web-based client over an interface. So we have behind a REST API that serves up all the data, and all interactions with the database happen not through, never directly through the database, but through this REST API. All the data models and concepts are based in ISO 11238 inside of there. We have a legacy support mapping to other data models through data code tables or code sections. So our JSON is the default way that we exchange information. So all the structural information is actually based, all the substance information is based on this JSON schema that we've developed, and all interactions with the server, with the API back and forth, are based on those adjacent formats. The software that's produced is deployable in JSON containers like Tomcat or WebLogic or Glass. Fine-grained access control at the API level, so that you can say certain things about who can see things and what jurisdiction and what role that user would have to be able to update, change, modify, and improve this information. Interest is things like what the relationship stability. It turns out that there's sometimes where the majority of information around a substance is domain and freely distributable, but there's just one little piece that's enough speed, and all that piece will connect to other pieces. So there's a little bit of you always need to have somebody look at this, but we can accommodate any level of fine-grained reproducibility you want. So we're also agnostic. So we can connect to Oracle, MySQL, Postgres, theoretically, and then there's a translation layer where that's indexed into the database. Structural handling of documents where possible, and so our open source where possible. And that's been our slide as well. A view of what this thing is. This is maybe a little more detailed than the previous one. Is we have three main services. We have a renderer, we have a front end, we have an API. So going from the top down, the database first, the database. By default, we package it with H2. It's an embedded database just for simplicity. That's where the data is stored and indexed. Then the REST API connects to this, as well as to some indexing services that we have built into the API. For certain things like free text indexing, that's Lucian indexing, critical structure indexing, that's our NCATS chemical indexing, having nucleic acid and amino acid indexing, which is the third component. So all of these indexes help to facilitate the data to be highly searchable across various domains. This is in contrast to some other systems that might, for instance, use plugins or cartridges on top of a certain SQL flavor, like a Oracle queries and submit to that REST API, and that's how all the substance information is communicated back and forth to the front end. So someone could develop their own front end to do the same thing. And then the front end also just as kind of part of the front end, there's a renderer service which is used just for helping to show samples and things that are related to particular things. So that's the renderer in the future be wrapped up together with the front end, but right now we find it convenient to have outside because the renderer actually has utility outside of the whole effort, the whole software effort. There's utility that people will use this for. Okay. So the overview here, so there's a client-server interaction, as I mentioned, that's database agnostic. There's those pluggable engines for text structure and sequence searching. So the data right now, I have larger slides about this. Maybe we'll probably get into this later on, though. This is being bootstrapped from the FDA's public SRS data as well as some of our own data. We assembled this together, put it into the right data model to work on this GINAS system, and then the software along with that full of data as examples. So the instances can each one of these instances, I should say, has the ability to communicate with each other. We're still working on the best ways to make sure that communication. Right now, import and export, pushing and pulling is somewhat manual. That's an architecture overview. Just a quick example of something, I guess we're getting a little bit of time. So then what I wanted to mention was that one of the nice things that happens with being able to do things at the REST API level is that you can come up with some fairly nice tools to make your life a little easier. So with the REST API level, with those APIs that we develop, make this thing that I like the rest of you guys, but I spend a lot of time in Excel, way more time than I like to admit. And often what I have is something like this, where I just have like a list of names of something that I wanted, and I want to know what they are. So here I have aspirin and levatin, ibuprofen, and ADT. And maybe what all these things are, and I want an ID for them, or maybe I wanted to see what they are. So using our APIs, we can really quickly make software like this, so that we have something like, for these sets of names, we want to get out miles, the CAS number, the uni, and the name. So if we and then you'd be able to see what these things are. So here's the miles of this, here's what the uni is associated with it, here's some CAS numbers, and so on. And these things become fairly easy for other developers to make, as long as you have the API level there. And so this is something we've been starting to use internally here and evaluate. And I think we may eventually package it together with this application just to make things easier. So the time is not spent for most people spent in the registration process.